Let's start. That's the Tokyo Linux Users Group. Thank you all for coming. And let's start with introductions. Start with myself. I am Alberto Tomita. I have been with the group since 1994 or 5. I think I came starting from the second or third meeting. And I'm no longer using Linux at work. All desktops are Windows. And I'm no longer doing sysadmin, so I'm not even touching any server. But my PCs at home are all running Linux. My laptop is running Mint. And that's the extent of what I use in Linux.
What are you doing now in work?
Good question.
Are you management?
Yeah, Excel, PowerPoint.
LibreOffice? No?
Huh?
No LibreOffice?
No LibreOffice.
Oh.
Actually, we will start introducing LibreOffice. That's a good step forward for Windows. Sure.
So what's the plan for Windows 10 for your?
Windows 10, it is in the roadmap.
Be sure to check off all those privacy settings. I've heard it's like 13 pages. It's very simple. Just turn everything off, and then it still phones home. But at least you have a choice, right? In a corporation, you have a choice. They're not pushing it on you yet. They'll give you. They're not going to automatically update corporations. I mean, you do it yourself. But this way.
You mean that now
at different stages.
Do you want to upgrade now?
Yeah. Now or tonight, and down here it says later. There's no never. So millions of people are downloading this third-party app. Have you heard of it? It's called like
Windows?
GWX update, whatever. Can you believe that? So if they trust like some stranger somewhere more than they do Microsoft. Steve Gibson on Security Now the other day said Microsoft released some official patch that they make hard to find to stop those forced updates on you. They're pushing Windows 10. He said he ran it, and then he ran like several months of updates. So a lot of people were just turning off Windows updates altogether. That's how bad it's gotten. Anyway,
let's move on.
That was my introduction.
Jim Titzler. I've been coming to TLUG since we used to meet for lunch and then drift off to someone's apartment to play with Linux and then drift off somewhere and play laser tag. I use Linux at home and at work, usually one of the Ubuntu flavors, although nowadays it seems like everything is in a Docker container, so nobody cares anymore.
Okay, I'll go next. So my name is Andreas. I'm from Belgium. I've been using Linux since 2007 when I was working for Opera Software, who now apparently got bought by a Chinese company. Then I worked for Oracle for a little bit, and not too happy about my experience there. But then I came to Japan in 2010, started coming to TLUG, actually to find a job. That it worked out. Somebody here introduced me to my current company, whose software I will be presenting today. And after I found a job, I kept coming because Linux and TLUG is awesome.
Okay, I'm Eric. It's my first time to come here. I'm using Linux for about 10 years on my main computer, and I'm running the NixOS meetup of Tokyo. So if anybody is interested, we have meetup next week. NixOS.
Jim said Yasu is involved?
Yeah.
Yasuaki, I've known him for like 20 years when he was a college student.
Yeah.
He used to come to the Tokyo PC Users Group meetings, and then he'd have to run for a train to go back to Tsukuba. Remember, but he would just stay at my place. And
it's a small world. I know him from Haskell meetup, and it's just like.
So I'll try to get there someday.
Hello, I'm Quentin. I'm from France. I use Linux at home, and I was using Linux at office in France. I moved to Japan in June last year, so now it's only for personal purpose. And I started with Linux when I was to college or something like that, some time ago. And actually, I look for a job on Linux. To use Linux at home and at work.
Are you a programmer?
I'm between QA and DevOps.
I see.
Okay, between the IT and pure development.
I see.
Hi, I'm George. I rejoined the group after about 10 years, and I'm using Linux for work. I do some scientific programming. So I saw first time Linux at Red Hat 5.2 about 15 months ago, and I like it very much.
My name is Jim. I'm been here working in Japan for a while, doing on-track data recovery. We're mostly a Windows shop. I use sometimes I use OpenSUSE to help with data recovery work.
I'm Michael. I was system administrator. Been using Linux for a long time. Manage servers of various types out in the cloud for a number of small office clients. And I recently have been doing a lot of coaching for getting people off of Windows to Linux in a small spin-off group from the PC Club called Control IT Works. And that's actually going quite well. It's surprising.
And what language is that fluent? Is it like English like this or?
In German, it's
Mix of both. And if you want, you can also use a BeagleBone Black computer and running kind of Debian.
What kind of people do you usually get? Are they already kind of technically inclined or like housewives?
No, actually, one person walked in the other day and said, wow, this is like the club of the gray. It seems like it's a geriatric club because everybody has gray hair and is on the verge of retiring. Nevertheless, our goal is to keep people involved and learning, and that's going pretty well. This group is also a spin-off of my experience at the Tokyo Hackerspace. So we're not just doing programming, and actually this week we're working on setting up mail servers for the individuals in the group, sort of like looking under the hood, so they're not just using their mail client. But we are also doing electronics projects, putting things together. Are of great interest. Cockroach traps, I think, are on the agenda for next week. And we've done things in the past like guided counters and physical sensors.
Maybe I should drop by and bring down the average age.
Certainly would.
Okay. I'm Tim Osborne. This is my second meeting. I haven't been here too long. And, I've been using Linux since the early 90s and came on floppies.
How many?
80?
Yeah.
And then, I do network engineering full time. We use Linux at work and previously and all that stuff.
Okay, so hi, I'm Lulu, and this is the first time here. So I work for physics, so basically this is why I use Linux. I'd like to learn something from this. Thank you very much.
Okay, I'm Colin. I'm also doing physics. So we actually bought new watches this week, and I think they run Linux as well. So we're using Linux. And also from just from physics, all the people there use Linux for developers.
Your watch, you think runs Linux?
It's Tyson, it's an Android phone.
Does that school physics class or that's new?
It's nature, chemistry, physics,
Oh.
science.
So it's a class?
As a researcher.
Oh,
I'm Carl. I was invited by Alberto, and I think a lot more people are supposed to come here from the Australia school, which Alberto and I am. I used to run, I used to be part of the organizer of Boston Japanese Linux Users Group 1 years ago. My interests have shifted out in the recent years. I still use Linux because I work for a company, American company, software company, Initiative. We do distributed file processing. And our software runs on Linux and Windows and mainframes. So I use it mostly to run our software. But I've been away from the new everything. So it's kind of nice to to get reacquainted, and I think I should hang out more with people with similar backgrounds and outside of work, not just photography. It's nice to know all people.
Are you using Linux for your photo editing as well?
No, I'm not. I'm just not sure. That's part of why it's nice looking this, because I want Photoshop to run faster, and I know Adobe is starting to use more and more of the GPU. I don't know how it works with the old here.
And my name is Shin. I've been using Linux machine from early 90s, Blackware 0.9.7 with JLE language as an extension, right? And I believe that only Alberto was there when I joined TLUG in around 1994 or something. In this group, I mean that for some other grade older was just the president of the TLUG. Also, there are some other members, of course. But I'm not joining TLUG so frequently, but I keep using Linux machine for my job and for my hobby. And my company is called Akamai, and they are just using more than 200,000 machines in Europe. Right? They are all running Linux machine. And also my home server is just running Linux. But I'm not usually develop these things. I'm not running any code specs. I just use an operating on the machine. That's it. Thanks.
And I was going to say we have two great presentations today, but I'm not sure about the first presentation, so we have one great presentation today.
I'm not sure about that one. No, I do kind of like it, actually. So.
Right, so I will try to keep to about an hour or so, then we'll have a short break, then Andrea's presentation with the demo, and we'll try to get out of here before 4:30. Logistics, bathrooms here and there. There's a vending machine on the right side at the end of this corridor here. Be careful because it is just in front of another seminar room here. They're having lots of people there, so please be quiet. And if anybody wants to get out of the building during the break, be careful because you will not be able to come back in. So if you get out, make sure to note my phone number first, and then when you come back, you can call me, and I will open the gate for you. And let's get started. First, a disclaimer, this is a backup presentation. I couldn't get a second speaker today, that's why I'm bringing this presentation here. So it's far from being a good presentation, but we will try to cover the basics of photography. So we'll be about 70% just basics, and then 30% about the tools for Linux. And how many people here take photographies? Anybody never took any photography? Any?
Well, I take photos, but that's not photography.
Yeah, cameras and Yeah, we have cameras everywhere, so ubiquitous these days that everybody is taking pictures everywhere, anywhere. Okay, now let's see. How many people here know why a camera is called a camera? Yeah, good one. So the origins of camera.
Camera obscura.
So this is how people used to take pictures in the early days. It was just a darkroom with a pinhole, and the images were projected on the wall, and they just painted it. That's why we have cameras today. And an evolution of this darkroom, it is this one, a little bit sophisticated, has a mirror, and people can actually draw things in here. So, drawing with a camera, and that brings us to the origin of photography. It means literally drawing with light.
Actually, there's one thing I've always been wondering about. I'm not sure if you'll know the answer, but when like cameras and photography first came out, did people think it was going to put painters out of business? I think they probably did.
Yeah, that's why they started drawing non-realistic questions.
Right.
Right, so the principle back then and even today is still the same. We have a box with a pinhole, and the light goes through the object to some material that records the image. And if you look at an early camera, that's exactly it. That is a box with a pinhole. It has lenses, has a film, but essentially the same principle. And guess what? We all carry cameras with our eyes. These are also following the same principle. We have lenses, we have a pinhole, and the image gets projected in retina. Now, one thing to have in mind is that when we look at each other, we are not actually looking at each other. We are looking at the light that is reflected in each other, and that comes with our eyes. So, obviously, one important piece in any photography is the light source. So we are seeing the light, and we see in this room we have light coming from the windows, we have light from the ceiling, we have light from the projector, and we are seeing the image being reflected on the screen and come to our eyes. And one of the most difficult things in photography is to control the light, because objects, they reflect light in different ways, and depending on the position, depending on the surface, depending on several factors. Tara can talk about light forever if you let him, but it is a very difficult subject because light is not easy to control. One of the reasons for that is because light, it is an electromagnetic wave. So it is actually a wave that has different wavelengths, and what we see is just a small portion of the visible spectrum here. Then we have cosmic rays, we have microwaves, all the radar, television radio waves, but what we see, it is here. And expand to that, that's how we see the colors. So each color is a different wavelength. Now color comes from reflected light, and what we are actually seeing, it is the the light on the wavelength that is reflected by a particular object. So when we see blue, the light here is white, so contains all wavelengths, but when it gets reflected, we see actually only the reflected light of that particular wavelength. And when we see black, we are actually not seeing anything. It's because it's not being reflected. When we see white, it's everything being reflected. And now we are starting to get into one very difficult concept in color photography, that is white balance. That's because white may not be white all the time. It depends on the color temperature. So we see different sources of light may have different temperatures, and temperatures here is measured in Kelvin. And when you see an example, depending on the light source, you may have different temperatures of the light, and that, I don't know if it's, yeah, the projector here, it is good. You can see there is warm light here, and is a cold light here. Now, let's go back to the camera. So we've seen the early cameras. So let's see now how a modern camera works. It's still the same principle, nothing much has changed. We have light coming from an aperture here, there's a pinhole. Then we have a shutter, and the film, or in the case of a digital camera, it is a sensor. Now, it is called a single lens reflex, SLR, or for digital cameras, DSLR, because we have a single lens here. So all these cameras have a single lens in the front, and the image is reflected by a mirror, and through a prism, we can actually see the image that is coming from the lens. So that's how we look at the image before the picture has been taken. When we actually take the picture, when we press the shutter button, it's not only the shutter here opening, but also the mirror. It goes up, so all the light goes hitting the film or the sensor. Now, if you are wondering why it is called single, it's because there is also a dual lens reflex. So these have twin lenses, and one lens is for the purpose of sending the image to the viewfinder, and the other lens actually captures the image in the film or sensor. And thinking about it, I have not seen any digital dual lens reflex. Do you know if there's any?
I've seen toy ones. Look like that. But I'm sure they exist in small form.
Mm-hmm. And an interesting comparison between the human eye and a digital camera. As we see, the principle is the same. We have lenses, we have a aperture, and we have the film. And the main difference here is how the brain processes the image. It is actually capturing a very wide field of view, but while we have a picture here that is capturing all the details, the brain, it focuses on the important points of the picture, and that's where we have all the focus. And we have the peripheral area that is less detailed. That is our peripheral vision. and the technical specs of the human eye.
Is this going to be on the test?
I've never heard it. Specs. Oh, wow.
Oh, I've never heard either.
What's the variances on those specs?
Yeah.
Let's see. Sensor resolution has a very high resolution. But we can see here that when we focus, the details are actually only 74 megapixels. All the rest of the resolution here, it is coming from the wider field of view, but with a lower resolution in the peripheral area. ISO is actually not that good. We cannot see very well in the dark.
I'm not younger, though.
Yeah. Lenses, dynamic range, focal length, for aperture. Aperture is also not that good. It matches the ISO, so we are really not good in seeing the dark, but you can see that aperture, it goes to 8.3, so we can get very detailed images. Field of view, color space, sensitivity, and color range. So that's another area where it is far superior than anything digital. We can get more colors, more sensitivity colors than any sensor. White balance is automatic, and we have a refresh rate that it is very good in the full field vision, that is our point of focus. And why we are good in capture things that are moving in the periphery is because there the refresh rate is higher.
What's the difference between dynamic range tracking and
Good point. You understand?
I guess the brain adjusts. So 1 million to 1 is 20 stops. Okay. Usually the standard newest products from Nikon and Canon, the dynamic range that the sensor can handle in one frame is about 12 stops. But each click on the aperture rating is a stop, or each doubling of shutter speed is a stop, and can only cover 12 stops, and our eyes can do 20.
And I think Nikon has a higher dynamic range than Canon.
But even with a better dynamic range of Nikon, it's about 12 stops. Maybe the newest Sony can do better. 14 stops.
Right, so we started talking about the technical terms here, stops and ISOs and things. So what that means? Means that whenever we take a picture, we take into account 3 factors that is called the exposure triangle. So there is a balance between each one of these parameters. We can get good results by changing one parameter, but that may influence the picture somehow because it will distort the triangle. So what used to be a perfect triangle now become distorted, and the picture will look different from what we may expect. And why is that? Let's look at each one of these components separately. First, aperture. So the aperture, it is the size of the pinhole. It is made of blades, and these blades here, famous from the 007 openings. Every movie has a blade there. So that's the aperture. And it is actually in the lens, it's not in the camera. So each lens has its own aperture. So we can see here that this lens particular, it is 2.2. And there is a number called f-stop. And the smaller the number, the larger the aperture.
It's actually the ratio between the length of the barrel the diameter of the opening. So even a small lens in a smartphone can have a very large, low f-value.
Do you know why it's called f-stop?
I looked it up once again. Yeah. It's
Google.
DuckDuckGo.
I think it's focus.
It's focus.
But I don't know why it's focus. I think it doesn't have to do with focus.
No, actually, it does have something to do with focus because that determines the depth of field. So we will cover that in the next slide. But two important factors here is that obviously the larger the aperture, the more light we can capture. The smaller the aperture, the less light will come through the lens and less light will hit the film or sensor. But the more light we have, the smaller the depth of field. And what is depth of field? Depth of field, it is the distance through the main subject in front and behind that will remain focused. So we can see here that we have this area in focus and everything else is blurred. So we have a large aperture, a small f number, and we can see that only the center here is focused and everything else is blurred. Improves as we close the aperture, and with a small hole, f8, almost everything gets in focus. And that is because we have something called the circle of confusion. So this, the larger the aperture here, that will drive a larger circle of confusion here. Unfortunately, it's not in perspective, but if we take that in perspective, it's actually projecting a circle here. And the circle, as the aperture is big, the circle here will also be big. So that will put places out of focus as they go front and behind. The smaller apertures, that brings the smaller circles here, so that helps bring things that are in front and behind into focus. So that was aperture. The other parameter is the shutter speed. So we have the shutter that is actually a shutter that is opening and closing, and that determines for how long the sensor will receive light from the lens. So obviously, the longer it stays open, more light it will receive or capture. But one downside here is that the longer it stays open, if there's something that is moving, that subject will become blurred because it is open for a long time. So if we want to capture something that is moving fast, we use a faster shutter speed. So it opens and closes and captures just that moment where the subject is moving. The downside is that because it stays open for only a small fraction, it needs much more light because it's capturing less light. And the last one, ISO. I could not find a good definition of ISO, but I found this analogy that I think it is reasonably good. So the ISO, it is the size of the bucket. So we have light, that is water, coming in. We have the exposure, there is amount of water that goes in the bucket. And we have aperture, that is how much water will come out of the tap. And for how long the tap stays open or closed. So let's see. If we have a low ISO, it means that we have a very large bucket. So we need to have lots of water coming in. But if we have a small aperture, it means that we have to keep that open for longer in order to fill the bucket. So we need a longer exposure. On the other hand, if we have a large aperture, so if we open that, we have more water coming in, and we can fill the bucket in less time, so we can have a faster shutter. And the higher the ISO, the faster we can, the smaller the bucket, and the faster we can fill it in.
I think it would be more intuitive if the size of the bucket is actually different.
Yeah.
Because the change is not linear, it's logarithmic.
Yeah. I tried to Google that, but I couldn't find the diagram.
But it's a good diagram.
Right. But that brings the question, why we don't always use a higher ISO if it is faster to fill? It is because the downside of a higher ISO is that we have more noise in the image. It means that we are pushing the limit of the sensor, and it is an electronic device, and electronic devices, they have electron noise. So a low ISO, it gives an opportunity for the circuitry to shield all the noise that is around the sensor chip. But by increasing the ISO, that shielding becomes weaker, and we have all the noise being captured. So every noise in the image will be amplified by the noise in the chip, and we have a very grainy image in the end with a higher ISO. In summary, it's three components that we need to have a good picture. The exposure triangle. ISO, so we can have a low ISO with a very sharp image, or we can have a high ISO with a very noisy image. Shutter speed depends on the subject. If we have a fast shutter speed, you capture with precision just that particular moment of a very fast moving object. If it is a high shutter speed, it is exposing for longer time, so things that are moving becomes blurred. And the aperture. So the smaller the aperture, or the higher the F number, that's very confusing, we have a better depth of field. With a large aperture, or a small f-stop number, we have only a small section of the three-dimensional image being in focus, front and back becomes blurred. Now, I mentioned that the sensor, it is an electronic device. So that's what we find in place of the film, where in analog cameras, they had the film in the back. Digital cameras, they have a CMOS sensor in the back. When we go to big camera, the Bash camera, we can see that the camera section, it is classified in categories. So we have a section for small cameras, medium cameras, big cameras. Those are proportional to the size of the sensor. The bigger cameras, they have what is called a full frame sensor. It is a full frame because it has the same dimensions, the full dimensions of an analog film, of a 35mm film. Now, sensors this size are huge, cameras become heavy, and they are very expensive. To cut the cost a little bit, they came with APS-C. These are smaller sensors, and with smaller areas, we can have cheaper chips, and we can have cheaper cameras. And APS-C, it is also called a cropped frame, because if we compare the size of the picture between an APS-C camera and the full frame, we can see that it's cropping the image. So APS-C cropped sensor, they are used interchangeably.
See, how about micro four thirds?
That's next.
Oh.
Right, so micro four thirds, that's another format, and they make very small, lightweight cameras. Doesn't necessarily mean that they are cheaper, but and one advantage is that we can have micro four thirds cameras that are mirrorless. So we can take all the mechanical components of the camera to make a smaller camera. So that's this one here. So micro four thirds, it is using a sensor that is in the same dimensions of a 16mm motion picture film. And we can see in this example here that it's much smaller because they don't have all the mechanical portion or the optics here with the mirror, because the image is going directly into the sensor, and the image that is being captured by the sensor is what we can see in the display in the back, or in some cameras we have an electronic viewfinder. So the image being captured by the sensor is being sent to the viewfinder, and everything stays there. There are no moving parts.
What is the problem building a full frame with just the electronic viewfinder and no mirror? If you're going to have a full frame with just the electronic viewfinder, no mirror.
Sony RX1 and new oncoming products you'll see this year will have full frame sensor with mirrors.
So the past was just technical because they're smaller, it's easier to build microphone.
They're cheaper to build. That's why they started doing it. But there's also an advantage if you have all bigger format lenses, because they assume larger distance between the sensor plane and the rear element lens. So it's because smaller cameras are smaller, and the flange back, the sensor plane and the rear element of smaller cameras is narrower. So in theory, I mean, you can put some kind of a distance between the bigger lenses and the small camera. You use all the bigger format lenses and smaller format cameras. So if you have a lot of lenses from years ago, or if you want, for some reason you want to replicate the effect of all lenses, you can use them on the small camera. So some people choose small cameras for that reason.
Right. And the sensor. The sensor, it is a chip, and it has an array of CMOS sensors. The sensor array has some electronic here that is to convert the light that hits the sensor, and that sensor is converting the amount of light into some digital numeric figure. And that's where we have the conversion between something that is analog, like the amount of light, to a digital number. And most of the cameras, they capture images in color. And we do see video cameras that have 3 sensors, one for each one of the color components, RGB. DSLRs, typically, actually I haven't seen any with 3 single sensors. But since they have only one sensor, in order to capture all 3 color components, RGB, there is a color filter array on top of the sensor chip. And that array, it is filtering all the color components. So what we have, it is a matrix of pixels that are actually not one pixel, but is one component, one color component of the final pixel that will go to the camera. So while we may have here R, G, and B, so we will have in the final picture these 3 values here will form the final pixel in the final image.
And what's funny is that there are more greens than the blue or the red. Twice as many greens. I don't know what you found.
Is it really that's the case?
Yeah, almost cameras.
Cameras?
Yes.
And is there a sensor under each little square, colored square?
Yep.
And so maybe four components are making up the pixel?
Yes, yes.
Exactly.
Mm.
Some cameras, they use the anti-vibration, the dust removal mechanism to shake the sensor during exposure, or actually capture 3 exposures, and then compute
The average or
the average or
median or something? Mm.
It's a little more. It's more like anti-alias.
Does the shaking of the lens really remove the dust?
It
That's
does.
really pain about the cameras.
It does. Not every dust, but
That's been my dread about cleaning the sensors.
mirrorless cameras, because they don't have the mirror in front of the sensor, they are more susceptible.
What is the reason?
Yeah, I heard that the human eyes are, I think, more sensitive to green, and therefore to capture images that look more, that are easy for humans to get. They put more greens. Some cameras have figured out to put almost a random combination. It's still the same ratio of red, green, and blue, but instead of putting them in a square grid like that, they have like Tusi has a cognitive layout of that looks more random, and it's supposed to be better for color rendition.
Yeah, I think it was Fuji that they have the sensor where instead of having the square cells, these are hexagonal cells. So it makes different patterns.
Yeah. Also, Sigma has something called foveon sensor, where each pixel actually captures all of the colors. So they don't have a filter. They have more resolution, but also they don't have the filter. On top of it, so they're more sensitive. But they're slower.
And there are cameras that don't take pictures in color. They take only monochrome pictures, so they get rid of the color filters, and all pixels are actually mapped one-to-one with the final picture, so they have better quality. So, if you ever heard about RAW files compared to JPEG files, that's what it is. And excuse me a second.
Address. Okay. Okay, someone will go.
It's Bruce. He does this.
I would wait until he comes, but I will say now, I never seen one meeting where he came on time.
Oh yeah. Well, let's have some fun with it. What can we do? I mean, come on, you interrupted everything. That's all.
Right. So raw versus JPEG. The difference is that a raw file, it is doing exactly that. It is capturing the numeric values coming from the analog to digital conversion straight from each one of the sensor cells here. And these go into a raw file. And if you ever wonder why a raw file is so big, it's because it is taking all the values from all the pixels without any compression. It is just raw. Then, cameras also have a processor embedded, and that processor, it is doing a few things. First, it is demosaicing, so it takes all the 3 layers and prepares the actual RGB picture with 1 pixel. White balancing, some...
So I have one question actually.
Huh?
So the raw file, is that something different from RGB that still has like the 3 layers?
It is different. It is different because here it is still in the original layout. Here it is in the final layout, that is 1 pixel RGB.
Thank you.
Here is 1 pixel R, 1 pixel G, 1 pixel blue. Right. White balance is some processing on the image, and the final compression, and that compresses the final file into a JPEG file.
Are all the camera makers using their own format for raw file?
Yes. There is no standard format.
No standard, huh? Okay. How about within makers? Does like Canon use all the same format? C or 2?
Not sure.
Not sure. Okay.
No, they're all different because they're different. Every couple of months, Adobe comes up with an updated version of their Adobe Bridge, which reads your raw files on the camera and puts it into DMG file.
Oh.
Yeah.
Okay. Thank you.
Right. So from here, that's where we actually start editing the picture. So we have a few choices in doing that. So one choice it is just take the output from the camera processor, the JPEG file, and straight off the camera. If we are lucky, we get an OK picture. Now we can also take the same JPEG file and edit on the JPEG file itself, and we have something that will be okay sometimes. But if we really want to get a good picture out of the camera, editing with the full potential of the tools that we have, we use the raw file. And with the raw file, we can do everything that the processor embedded in the camera can do, and more, because we will be processing on the PC. So we have more processing power. And these are some of the tools that I use. I think I can demonstrate everything here. So let's go to the demo. something.
Does Google still release Picasa for Linux?
Yeah, I was going to mention that.
They announced today or yesterday that they're not going to release it anymore for anything.
Yes, they are killing Picasa. So yeah, the announcement came last night. So they will stop all development on the desktop version, and they are going to stop new albums from being created on the web Picasa. And they are asking everybody to migrate to Google Photo. But I still like this. It's a very simple tool. So that's the desktop version of Picasa. And I like it because it has two functions. Not only does all the image processing, but it's also a good picture manager because it scans the hard drive, and I have all the files, all the pictures in my hard drive, my directory, neatly listed here. So it's a very good organizer. Too bad they're killing it. So let's see what we can do here. Let's choose a picture here. And it is I forgot the mouse. And the basic is I can do an auto contrast and auto color, so that improved the image somehow. And what else I can do here? I can crop the image. Then apply some text. For example, I like this one. Put the focus here. And it's very simple to use. You just look at what you want to do here, all the effects or the tuning, and it is automatically reflected in the picture here. And the other good thing was that we could sync to the web album. So we could add the pictures here, and that would be in sync with whatever was online. And that was because
So do you think you can no longer recommend this program because
we'll no longer be supported?
Yeah.
Yeah.
Okay, can you show us another one? Anyway, I don't use Google.
Right. So The next one is called a Fotivo.
CR2. Canon, eh?
Yeah. He uses Nikon, I use Canon.
With any I'm going to do recoveries of these guys. I couldn't figure out format of any file. The internal format of any file. I'll search for it under this.
Right, so this is working on the raw file. And by the way, one thing that you can see here is the histogram. So it shows the distribution of RGB. And the good thing about this program here is that we have these tabs. So we have all the functions grouped, all similar functions grouped in these tabs here. And we can see, let's see, for example, we can work in contrast of this picture here. And one thing that it does is that every time we work in a parameter, it highlights here in green, and we can see that the green, the tab also turns green. So it's very easy to see which operation we performed on the picture. So we can.
What did you just do? Did you tap and lower the exposure?
No, actually, I've got catch Y, so it is taking this curve here and bringing it to the bottom.
Okay.
Can you explain the histogram?
Yeah. The histogram. So the histogram here, it is
It's I can talk about.
Okay.
It's the luminosity of, well, it's the it's the amplitude of R, G, and D at each luminosity level. So the lower end and the higher end is is bound by the three axes of the exposure, ISO, aperture, and shutter speed. Sometimes all of the signal sensitive effects is at the lower end, but at the upper end. As a photographer, you want to make sure that you fully you take advantage of camera's dynamic range as much as possible, so that all of the histogram fits within the lower end and the higher end. And so there's right now, when Alberto before Alberto started editing this picture, he had a beautiful histogram because there was nothing beyond the lowest threshold and nothing beyond the higher threshold, and he was fully utilizing the dynamic range.
What's the low and high end in relation to the? Is that the left
It's
or right
left hand side and the right.
Right.
Yeah. Can you revert your editing?
Yeah. I'm trying to.
So it has nothing to do with the left side of the histogram has nothing to do with position of the image. The position of the image.
It has nothing to do with the position of the image. It means if the histogram has a value at the very left hand side, that means the very darkest part of your image is dark beyond recognition. So you don't have any detailed information on that part of the picture.
Detail meaning a mix of red, green, and blue.
Yeah, it's a discernible difference between discernible. I mean, any useful.
So pure white would be
pure black. Pure black. It would be pure black. If the histogram has value at the left hand side.
There is
anything.
Edge, so really the edge, not the side, really the last thing.
Yeah. It would be pure black, so there's no information to be covered there. If you're a painter, you would always leave some kind of information in the you never paint a pure black.
Yeah, so let me use a tool that I'm familiar with so that I can show better how it works. So we have the histogram here, and we can see that is.
For some reason, that looks different than what we started with.
Is that the same picture?
Is it? Okay.
Yeah, it is. It is the same one, and yeah, it is updated.
Okay.
So
But that histogram has value on the right hand side, but I don't see any bright white spot in this picture. Weird.
The clouds, I think.
The clouds? The clouds are not pure white.
Not that much.
His mouse pointer is pure white.
Yeah.
The clouds.
What about the?
Yeah, but we can see here that as I brighten the image, the histogram tends to go to the upper portion.
So if you want people to see details in the white or the dark, you want to manipulate the histogram so that everything there's not Can you Alberto, can you lower the highlights so that there's nothing touching the right hand side of the histogram? Are you manipulating exposure?
Yes.
Can you lower the highlights and
highlight?
Raise the low shadows? So yeah, that is a global manipulation, isn't it?
Yes.
Yes, there's shadow and highlight. Shadow to highlight.
Okay.
Right there. Yeah. So the highlight, he can. Where's the? I don't see a knob. But anyway, he brought the highlight down so that the bright parts of he's only changing the luminosity values in the bright parts of the picture. So the details in the sky become more pronounced. It's interesting. And another interesting thing too is to raise the shadows.
Yes, shadow.
So you can see more detail in the water surface, in the darker part. As he raises more and more, it becomes a bit too artificial. Looks like someone's illustrator or something, like an album type of thing, 70s.
Right.
As a result, this histogram has more shapes around the left-hand side and the right-hand side, and that's typically what you want. So, when you record a picture with a camera, you try to make a histogram like that as much as possible. And when you come home, you take the raw file and do post edits to perfect that.
Yeah, but yeah.
Aesthetic end.
Yeah. But the idea is to get the right exposure triangle. So with the right exposure triangle, you have the right histogram here. And I changed to another application called Darktable. I use this more than the other, so I'm more familiar with this one. And some say that this is the equivalent of Lightroom that is available from Adobe. The difference that this is free software.
This is Linux still?
Linux.
It's open source?
Yes.
It is?
Yes.
Timetables not available on Windows.
Yeah, it is available Mac and Linux, but not for Windows. And the setting that Tara was interested with is the one that uses GPU. So we have a GPU acceleration somewhere, but will not be made on this laptop because there are no GPUs in the laptop here. But one of the features is that of this of this software is that it uses OpenGL, and with the OpenGL API, it takes use of the processing power of GPUs.
Does it tell you what effect it uses the GPU for?
I
guess not.
No, I never looked into that. But I think it's used for everything, including exporting the file, rendering, because when I do that on my PC at home, everything is closed down. So it's not only the CPU, it's using the GPU as well. Right, so similar to Fotivo, this also has the different modules for manipulating. This is manipulating the exposure. This is for the level or tones, colors, and other effects. So in the end, he is doing the same thing that was in this tabs here.
So how would you compare this to that table? What do you want to do?
I started with Darktable, so I got used to that and never really tried other applications on. I only know that it exists. I installed here just to see how it looks like, but never used it really actively this one. And there is yet another one similar to this that is called raw therapy.
Do you know any of these programs that features like spot removal?
Yes. Let me show it. In Darktable, for example, here we have the spot removal. If I enable this one, there are not many here, so I'm not making a difference.
This is like
Right, so this one is called raw therapy, and it is the same principles. So we have all the same functions that were found in Fotivo and Darktable are also here, also grouped by function. And
you find yourself using just one or a couple, depending on
yeah, again, for this one, I just installed and I never really used this one. I just
use Darktable exclusively.
All the time.
I think Darktable is the most popular software of this.
Yeah, it's the most popular and it has more active development than the others.
Is it easy to apply white balance profiles to photos with Darktable, or?
Yes, so let's see. So white balance it is in so this one. So for this one, I'm using the camera white balance. I can change, for example, to a cloudy or.
If you've got 50 photos and the white balance should be identical for everyone, you can just easily apply a white balance to all 2 feet?
Right, so what I can do here is I can create a preset and I can apply the preset to multiple pictures.
Oh, that's very different. What was the preset you used?
No, I just moved the slider here.
Well, change the color
Yeah.
component.
I changed the white balance.
The white balance.
So why I think it was around here originally.
You can see how the histogram shifts more. It does.
Yeah, it was bluish. It was bluish and then changed to that. So that's the effect of white balance.
Can you pick something out of a photo and
Yes.
call that white?
Yes. Yes. So I can. Okay. I can say that this is white, and you use this as reference, and you white balance saying this is white, and adjust the colors of everything else in the picture.
You usually incorporate area.
Now, one neat feature of this one that I didn't find in any other software is this equalizer here. And this one, according to the manual, it is manipulating the wavelet components of the image. Instead of manipulating in certain parts of the image, I can manipulate in certain frequencies, and that will give different looks to the image.
So lower the frequency, more blurry it looks, right?
Yeah.
And higher the frequency, more acute. What's the x-axis and what's the y-axis?
Here it says noise ka and komakai. Right. Right. So this must be the high frequency components, and this must be the low frequency components.
Okay.
And be conscious of time. Let me just show you 2 other the things that have nothing to do with editing, but they do image creation.
It's okay.
Right, so this is called luminance HDR, and the sole purpose of this one is to create high dynamic range images. So we saw that cameras, they have a limited dynamic range. So one way of amplifying that dynamic range is to take multiple pictures, each one with different exposure values, and as we compose all together, we can create of multiple pictures, we can create one high dynamic range picture. And I hope I have an example here to show you the same. This one. This one.
Does darkening do HDR?
It does. There is an HDR function, but I never use it. That I don't know how to use it. Oh, it crashed. Great.
Did you lose it?
Crashed.
It's not just busy, not multi-friendly either.
Let's try.
So could you show us which 3 pictures you have loaded in there?
Yes, I will. Okay, so while it is computing here, these are the original pictures. So we have so that's one. Two. And 3. We don't have a JPEG. I don't have a JPEG, but this is the third one. So we can see that we have one that is underexposed, and then another one.
But the sky is blue like Alberto wants.
And then another one that is, it has the flowers and the leaves more or less with right exposure. And the last one, raw therapy autocorrected the picture, but originally it was overexposed. But we had the trees here with the right exposure. So let me bring the result of these 3 pictures together.
Is it slow computing?
Yeah. That's why everything here is slow. Okay, I will give up trying to compose the image here on the fly. It's too much for this little laptop here. I know it's here, but why? Why so heavy?
It looks like it's still doing its work.
Well, maybe does that give you how to combine them, the pictures?
But it says cancel. It doesn't say okay or accept.
Just
No,
finish.
there's a finish here, so I'm trying to press. I'm trying to press finish.
So we haven't started.
So
No, it's doing something else in the back of the disk.
yes, there you go.
Okay.
We could always do the short break and let it work.
That's one idea.
I have two slightly related questions.
Yes.
But go off on a couple tangents. Personally, I take a lot of family photos, so what's a good photo manager?
Photo manager.
Yeah, like help to make my photo album or a catalog or to make a collection of photos, right?
Because I was a good
Okay.
for a casual, photo shooter.
Casual.
Because what it did, it had its smarts to look at the dates on your files.
Yes.
And regardless of where you import, it would put everything in chronological order, which is really intuitive for a human, right? But it's not that anymore. So I think the best choice is probably that table if you doing it.
Okay.
Or Lightroom. Which, that table I think is it's just like what I mean.
Are you looking for a way to present them, or just a way to
Manage.
manage?
Just to manage them.
Yeah.
Roughly.
So what Lightroom does, it has a database. It uses SQLite to catalog all your photos.
Oh.
You can rate them, you can give them stars of different color codes. And it has all the basic functionality of editing there. So, and you can put in as many tags, your family names,
Yes.
friends' names,
The event's name or.
yeah, the next user's group or whatever.
Mhm.
And then you can do a search and it will identify everything. And then, in addition to just cataloging and tagging and rating, you can make collections. So you say this is the best picture from family Christmas, or picnic or reunion, whatever.
Right.
Then some photos may appear in more than one collection, right? So it's collections of just collections of metadata. There's a tag mechanism, so it doesn't eat up much space. So it allows you to catalog things as you want.
Good.
In that much I know that table does. I don't know. I don't use that table. I'm a Lightroom user, but I imagine the same things is possible. Lightroom allows also to publish collections to Facebook, Flickr, Google Bars, whatever, or even your own website. And you can say for this website you want pictures to be exported as 900 pixels wide and 600 pixels high. Or for other websites you want the full resolution, whatever. And whenever you edit them, like make the highlights low, darker, whatever, all you need to do is just publish, and then different size pictures will be automatically uploaded to whatever service you use. So it's very comprehensive.
Yeah, so I'm giving up in trying to produce the image. That's what I have in the disk. So that's the final high dynamic range image. So this is the combination of this one, and the other one that is was even brighter. So getting it all together gets a good balance with a good saturation. Okay, now since I'm running out of time, instead, and I'm not sure if I can do it in this laptop here, the last one I wanted to show is called hugging. And what it does is create panoramas. So let me show you this panorama here. And we can see that there is some blur here. That is because this was composed of multiple pictures. And as the panorama was being composed, I also overlapped some portions of them. And one thing that this software does particularly well is that it not only stitches the pictures together, it equalizes the brightness, so it chooses all the best pixels from each one of the panels. And in the end, we also have a well-balanced, in terms of brightness, well-balanced picture.
What is this software called?
This is called, bring back my presentation. Okay. Right, so that's called hugging. Hugging. Right, and so I think I covered Picasso, Positivo, Rotary, Dark Table, Luminance HDR, and this last one, hugging, for panorama creation. And the last one is the workhorse of all the photo editors, that is GIMP. Right, so GIMP stands for GNU Image Manipulation Program, and it has all these different panes for tools. And let me open the picture here. Right, so it has also by category all the different parameters that can be manipulated, and it also works in layers. And one of the useful things about this one is that it has lots of filters, so we can do all kinds of processing here. We can spend days trying to play with all these filters. Let me show you from some of the pictures I have here, some of my favorite filters. So this one, being the original image, and then after processing, of this one. You can see here the original and the processed one. And here, one thing that I particularly like is this filter here called sun flare. So it adds the sun flare artificially into the picture.
All right.
Now this one. All right, so is this one was open there? So here you can see that we have people here in the background. I stood here for 10-15 minutes waiting for them to move out. They didn't. So what I ended up doing was removing them.
So how did you do this?
With the filter called, so one way of doing it is
Dehumanize.
Sounds like a middle band.
right, so one of way of doing it is coming here, and then I carefully determine the area that I want to eliminate. And then there's a filter here called resynthesize, and that will copy pixels from the surrounding areas and will synthesize into the area you want to eliminate. And there are several parameters here to work with. We can work with horizontal tiles, vertical tiles, and we can see neighborhood, and then it compares the pixels based on the likelihood of being fit for that area or not. And the ultimate result is that it eliminates people from the picture.
Can you click OK? Whoa.
Yeah, show us.
Come on. Decapitate.
Yeah, not so good.
Oh,
He took pictures
you
from
got
this
the-
area
the
here.
brown there on the right, huh?
Yeah. It takes time to find the right parameters for this.
Hmm.
It's a little bit easier on the
Probably. Yeah. And lastly,
We did get rid of them though.
some others that I have not tried. One is called Light Zone. This seems to be as powerful as Dark Zone. I haven't tried yet, but
dark table or the
as a Dark Table, yes. One thing that it does is that instead of working with areas, it automatically selects the zones based on the characteristics of the pixels, and then it applies all the changes to both zones. So I have to try that one too. Then this one, while I was making this presentation, this one also came up high in this course. Don't know what it does or how different it is. UF raw, this is a raw to normal format converter, and the one I want to try with this one sometime it is to use a GIMP plugin for UF raw, so I can read raw files from GIMP. GIMP natively it only works with JPEG files.
oh,
Yeah. And this one, it is not open source, not free, but also came high in the reviews. It is a commercial software from Corel. Didn't even know this use this, but it's in business apparently. Okay, that's all. Thank you.